volume causes hypoxemia, activates various pathways, and probably some of them, we have not explored them, I'm sure, decreases soluble vanillate cyclase, and causes a significant cytokine upregulation in the diaphragm, and these cytokines also escape into the circulation. Thank you very much for your attention. Oh, and these are all of the people, my apologies, that have worked for these experiments, and I thank them a lot.
Thank you very much. Very interesting presentation. We have time for a few questions. Art Slatsky, please. While he's waiting for the microphone, could you please give him a microphone? Let me just ask you on your model, how constant is the restriction you are doing, and what is its impact on the lung volume? So these experimental animals, are they predominantly with an increased lung volume, or is it so resistive that they are actually their lung volumes remain normal or even reduced?
Well, the pure inspiratory resistance model, the initial rat model that had inspiratory resistance, you don't have a reduction in the volume because it is purely inspiratory. Now, we don't have a means to actually quantitate the lung volume in our model. In some animals, we use esophageal pressure just as a surrogate marker. The baseline didn't seem to change, showing probably that the end expiratory volume does not change. But the problem is that if you do resistance and the animals are breathing hard and quickly, sometimes they activate also the expiratory muscles. So what we are getting is not actually a baseline condition, and we don't have a real solution to that problem to really answer you the question. Just guessing.
Yeah, okay. Art.
So Theo, very interesting results. Can you tell us a little bit about the mechanism? Because you talked about lung injury, but if I understand it right, there's obviously a marked drop in pleural pressure, but there's also a marked drop in alveolar pressure. So the pressure across the lung is greatly changed. So what's the actual physical mechanism causing this?
Well, when you have an increase in the resistance, what is happening? You have a transcapillary increase in the pressure gradient. Because you don't have a very good transmission of pressure, the transcapillary between capillary and alveoli increases. And this has been shown in big animal experiments in the 70s. So that this is probably the mechanism that really stresses the lung and causes the injury at the alveolar capillary membrane. We cannot prove it in our model, but this has been shown in sheep models done in the 70s. They have actually measured the intracapillary pressure upon resistance. They have done resistive breathing, as we have done, and they were able to have catheters to measure the intercapillary pressure and the pleural pressure and the alveolar pressure. And what they have seen is that by having the resistance, you just increase the transcapillary pressure, and this causes probably the initial mechanical insult to the lung with all the other consequences. But we have not any means to do it in rats to be sure that this is a mechanism in our model. This is just a guess.
Further questions? Yes, please.
Did you by chance do any bronchoalveolar lavage studies in humans with post-obstructive pulmonary edema to see if it's actually an inflammatory exudate and not the transudate that we always thought that it was?
No, we have not done that, but we are now doing an experiment again in humans, normal volunteers. I don't know how normal doctors are, but usually they are volunteers. And they will be breathing through inspiratory and expiratory resistances, and they will do after induced sputum. And some of us, like myself, that are more brave, probably, I'm not sure, are going to do bronchoalveolar lavage before and after. So we are currently doing the experiments. I don't have the answer. We are trying to prove the concept. But it is a time-dependent phenomenon. And you know, when you have a severe asthma exacerbation on an asthma attack, you might have it for 4 or 6 hours. But when you do the experiment in the lab, you usually do it 30 minutes, 40 minutes. You can have easily someone breathing 4 or 5 hours into inspiratory resistance. It's really tiring.
So I think if there are volunteers in the audience for these experiments, you are welcome to contact him afterwards. Okay, I think we'll have to move on for the
Could I
sake
ask
of...
back-
Oh, one more
The-
quick question from...
Just what pressures are you working with? Like 6 hours resistive breathing, I mean, this can't be that very high load. It's a...
Okay, the animals usually have a PA max of around 60, 65 centimeters of water, and we're usually working with 30, 25, 30, 35, depending, and if you register all over the time, they don't develop exactly 50% all over the time, but on average, this is the pressures.
Not
the pressure
very high
range.
loads, in other words.
Sorry?
It's not that very high loads, like 30% of maximum?
No, it is around 50% of maximum.
50%, okay.
It is high load, but